The aim of this video is to think about the various forms of demographic data that can be entered into POPGROUP to encapsulate the components of change, fertility, mortality, and migration, and to think about how POPGROUP processes these different forms of demographic data to produce projections, but also to think about the priority that POPGROUP applies to different demographic inputs. So to recap the cohort component projection methodology and the way that POPGROUP applies this, in POPGROUP we specify a whole set of Excel files which contain information on our population base, fertility, mortality, and migration. So we start off with our population base at the start of the projection. We take away any special populations and age that population base on after taking into account fertility, mortality, and migration, for which POPGROUP has a separate file or files for each of these components of change. Special populations are added back in, and then we go through this cycle repeatedly until we get to the final year of our projection, at which point we're given a whole set of output reports by POPGROUP. So it's these input files that I want to focus on in this video. So these input files contain a set of assumptions, and these assumptions can be very broad brush, or they can be very detailed, including, for example, the exact counts of births or deaths or migration that we wish our projection to replicate. So when we run the NRS 2016 population projection for the two council areas that we considered, Edinburgh and East Dunbartonshire, looking in the input files, one can see a whole set of different input files for fertility, mortality, migration, and so on. And these relate to different assumptions around fertility, mortality, and migration that the National Records of Scotland have produced. So plausible scenarios of high fertility or low mortality, and so on, that we can pull into POPGROUP to produce different or variant assumptions using our scenario files, which specify different inputs in terms of these components of change. What I'm going to do in this video is look into the information that's contained in some of these files. So for each of our fertility, mortality, and the 4 files of migration that we have within POPGROUP, the only requirement is to specify a standard schedule. And this standard schedule contains a set of age and sex-specific rates of mortality and migration, and a set of age-specific rates of fertility. We can explore these schedules using our input files. So what we'll do now is open one of these input files. So the one that we'll look at is the one that was used in the projection, the fertility NRS 2016 principal projection. So when we open an input file, one thing you'll notice is that these have a fairly standard structure. They tend to have several sheets. Usually all files will include a schedule sheet, which contains the rates are specific to each individual year of age. So we have fertility rates, mortality rates, and migration rates. We'll also have a note sheet, which will contain documentation that you as a POPGROUP user would enter on where the data comes from. And then we have a sheet called total. So this is a sheet with the assumptions that apply to all of the areas that we have included in our model. And we have a sheet for each area. So in this case, a sheet for Edinburgh and a sheet for East Dunbartonshire, which contain assumptions around fertility, mortality, and migration for these particular places. If we think about other input files, the constraints file and the population base file don't have a schedule sheet because these don't deal with rates of population change. And the scenario input file is unique in that the purpose of this file is to list the input files for a particular projection. So that scenario file doesn't actually contain any data. It's possible when you look at an input file to validate that input file. So here POPGROUP is checking that all the required information to produce the projection is present. And one of the things it does as part of that validation process is it produces a schedule of fertility, mortality or migration rates that are being applied in each of the population groups within our projection. So here is a validation of the fertility file in the National Records of Scotland 2016 based projection, and we can see here the fertility schedules for Edinburgh in black and Eastern Bartonshire in red, indicating higher levels of fertility in Eastern Bartonshire, but a similar shape of fertility schedule in that the peak of fertility is about at the same age in each of our areas. So I mentioned that there are a whole set of different demographic inputs that one can enter into POPGROUP. And POPGROUP has a very strict sequence of calculations for each year and each area in the way it applies the different inputs. So POPGROUP will always start off by looking for a schedule, a standard schedule of rates, which is a set of age-specific rates for the particular component that we are interested in. And it will apply that schedule to our base population to estimate fertility, mortality and migration. POPGROUP then looks for a quantity called differentials. And these differentials are a number which is multiplied by the schedule to either raise that schedule up or down to indicate higher levels of fertility, mortality or migration, or indeed lower levels of the same components of change. We can also specify in POPGROUP demographic statistics such as the total fertility rate, the standard mortality rate, or the standardized migration rate. And POPGROUP will look for these statistics after it has applied any differentials to the schedules. And it will alter estimates of fertility, mortality, and migration so that the values we enter for example, the total fertility rate are replicated by POPGROUP. After POPGROUP has ensured that our estimates of fertility, mortality, and migration replicate any information we apply around total fertility rates, standardized mortality rates, or standardized migration rates, it will then look for counts, so counts of births, deaths, and migration. And it will ensure that the estimates that POPGROUP produces replicate any counts of births, deaths, and migration that we provide for particular years. And then finally, POPGROUP will look for constraints, which are contained in the constraints file. So these constraints might, for example, be a population target in a particular year that a planner expects as a result of a housing development. So POPGROUP will ensure that the POPGROUP projection model meets that constraint in a particular year. And the way that it will do that is by adjusting migration estimates to meet the population target or constraint provided. So let me look at some of these demographic inputs in more detail. So if we're talking about a schedule, this shows a schedule from an input file on migration. This contains a set of age-specific rates of migration. And we use these to multiply the population of that age at the start of the year to give an initial number of the particular component of change. So in this case, we're looking at outmigrants from the UK. If we don't provide a schedule of rates for one of our areas, then the standard schedule of rates is applied. You might notice some red triangles in some parts of the input file, and if you hover over those, they show notes to explain the terms and rules of data entry. So differentials are a number that we use to multiply the schedule's rates. And in general, if we have a differential above 1, that leads to a higher rate than a schedule, with below 1 giving the opposite. and a differential of 1 makes no difference. So we can use these differentials in a number of ways. We can use them if we apply them within an area to reflect higher or lower levels of a particular component of change in that area. But we can also use them to capture change over time. So we can use a differential to capture change in fertility, mortality, or migration over our projection period. So in this particular example, you can see that all of the fertility differentials are equal to 1 as we progress from 2012 to 13 up to 2015 to 16. So in this case, the assumption is of no change in migration over the 4 years that we can see in this screenshot. We can use a whole set of summary rates, such as the total fertility rate, the standardized mortality ratio, and the standardized migration ratio, to scale our projection up or down to meet a particular level of fertility, mortality, and migration. So we can use these, for example, in the fertility context to ensure that our fertility rises to a specified level. So we might be interested in saying, what are the consequences of fertility being held at replacement level over the duration of the projection period? Replacement level fertility usually operationalized by a total fertility rate of 2.1. So we can specify that level of fertility and require POPGROUP to estimate fertility to meet that level of fertility. And finally, the final demographic input, or the penultimate demographic input, are counts. So counts override the initial counts that schedules of rates and differentials and any summary rates have indicated. So using these counts of birth, deaths, and migration, we scale the initial results for individual ages. And we can provide counts as a total, or we can provide counts for age sex groups, and indeed these can change over time. So here we have a migration input file where we're providing age and sex detail of migration over a number of years. So just to summarise, the kind of sequence of calculations for each year and each group that POPGROUP goes through is to start off with a schedule, to apply that to the base population to get an estimate of counts of births, deaths, and migration, but then to scale that schedule with any differentials to either raise or lower the levels of our components of change in areas or over time. We can provide summary measures such as total fertility ratios, and POPGROUP will adjust our estimates of birth, deaths, and migrations to replicate those summary rates. POPGROUP will then look for counts of births, deaths, or migrations and ensure that the projections or estimates match those counts. And then finally, it will look for constraints. So constraints might be a population size in a given year that POPGROUP will adjust migration to ensure that that population constraint is met. The only thing we have to provide in POPGROUP is a standard schedule. All of the other inputs are flexible for the user to add in and adapt to the data and assumptions that they have. So we can see clearly here that there are more than one way of making the same projection. If you're interested in more detail on how these POPGROUP calculations are calculated, the reference manual has much more detail on the inputs and how they affect the projection. So just to summarise then, the sequence of calculations for each area and for each year is as follows. So POPGROUP is looking first of all for schedules, so sets of age and sex specific rates, fertility, mortality, and migration. It'll then look for differentials to either raise or lower that across different areas or groups and over time. Then POPGROUP will look for summary demographic measures. So measures such as the total fertility rate, standardized mortality ratio, and adjust its estimates and projections of mortality, fertility, and migration to meet these summary measures. Next, it will look for counts of births, deaths, and migration, and it will adjust its projections and estimates to meet those counts. And then finally, it will look for constraints. So constraints may be population targets in particular years that are implied by housing development. And those constraints will be met by usually adjusting migration to meet the population target. The only thing that one needs to provide in POPGROUP is a standard schedule. And you can imagine here that these inputs are flexible for the user to be able to adapt the data and assumptions that they have in different ways. And a really important point here to make is that there is often more than one way of making the same projection. So we can specify schedules, differentials, and counts in different ways to get the same end results. And it's the case that for the data modules that we use to produce projections of population for Edinburgh and East Dunbartonshire, replicating those produced by the National Records of Scotland, certainly do contain more assumptions than are necessary. So the schedule and differentials that are provided within the input files are enough to reproduce those projections without the counts and constraints that are also provided. The constraints alter migration to force the projections to meet a target population or housing or jobs, as I mentioned earlier, and the reference manual has more detail on these inputs and how they affect the projections themselves.